Welcome to Pure Physics. This is Shrey Kushal here. Today, we are going to see about the topic electric field due to an electric dipole on its axial line. So before entering into this derivation, we need to know what is a dipole and what is an axial line. So first, dipole. Dipole is nothing but two equal and opposite charges. Two equal and opposite charges separated by a small distance of 2a constitutes an electric dipole. Now, what is an axial line? Axial line is nothing but it is a straight line passing through an electric dipole, or a straight line passing through two electric charges of an electric dipole is called as an axial line. So now we know what is an axial line, and I am taking this line to be in the x-axis. The two electric dipole is in x-axis for my derivation. So now, before entering into this derivation, we need to know one thing, the formula for electric field, because we are going to find the total electric field at a point due to an electric dipole. So what is the formula for electric field? E vector is equal to 1 by 4 pi epsilon naught q by r square p cap. Whenever we write the vector symbol, we need to write a unit vector. Unit vector is nothing but the direction of the electric field. Now we need to know what is this epsilon naught. Before this epsilon naught, I'm going to write one equation. E vector is equal to 1 by 4 pi epsilon q by r square into p cap. This epsilon is called as absolute permittivity, and this epsilon naught is called as permittivity of the free space or vacuum. Now why I am taking this epsilon is, I don't know what the medium is. In what this whole diagram is kept, I don't know. So before knowing that, I'll be writing epsilon. So in the place of epsilon, I'll be writing 1 by 4 pi epsilon naught epsilon r, because the formula for epsilon is product of relative permittivity and permittivity of the free space and vacuum. So in the place of epsilon, I'm going to write as substitute epsilon naught epsilon r into q by r square p cap. So when I know that the whole setup is kept in air medium, the relative permittivity becomes 1 in air medium. The relative permittivity becomes 1 in air medium. So when epsilon r becomes 1, I get the formula epsilon naught is equal to 1 by 4 pi epsilon naught, because the epsilon r becomes 1, and so I get anything multiplied by 1 is anything. So 1 by 4 pi epsilon naught q by r square p cap. So this formula matches with this formula. So this is the starting step. To get this formula, I took this formula as a starting step, and I arrived using the epsilon is equal to epsilon r into epsilon naught, and I got the final equation to the assumed equation. So now I can say electric field of an electric field due to an electric dipole on an axial line is kept in air medium. So when the whole setup is kept in air medium, I'm going to use this formula, because my since in air medium relative permittivity becomes 1. So now moving on to the diagram. So before starting our derivation, we need to draw the diagram. Then we need to explain the diagrammatic notations that we have used in the diagram. Then we need to give the introduction of the derivation, and then we need to step into the derivation. So writing the derivation, you need to specify what are the things you're going to use. And in the derivation, you're going to write some statements while you're going to substitute the formulas. Now, let us move into the diagram. So I have taken AB as the electric dipole. At point A is the minus Q charge. Minus Q charge is nothing but negative charge. And at point B, I have plus Q charge, which is the positive charge. And I've taken point C as the observation point. Now, as I know, an electric dipole is nothing but two equal and opposite charges separated by a small distance. 2a is called as an electric dipole. So the distance is 2a and it is equal. So the midpoint of a dipole is O. And when a midpoint is created between a line segment, it divides the line segment into two equal half. So I get AO as A and OB as A, since AB is equal to 2a. Now, I am taking a point C as the observation point, and the point C is at a distance of r. From the midpoint of the dipole. The point C is at a distance of r. And I need to find the distance between B and C, as well as A and C. So to find the distance between B and C, I'm going to use the formula as OC. I know OC as is equal to r, and I need to know what is BC, and I know what is BO. BO is A. So to find BC, I'm going to subtract OC minus BO, which is nothing but R minus A. BC is equal to R minus A. We are going to see about the distance AC. AC is nothing but AO plus OC. I know the distance of AO, which is nothing but A, to substitute A, plus OC, I know the distance it as R. And I'm going to put AC here, and I got AC is equal to A plus R. Or I can say, since addition is commutative, I can write AC is equal to R plus A. So now I'm going to start with the derivation. So first I'm going to write the general equation. It is nothing but the formula for electric field. General equation, it is nothing but the formula for electric field. Now only we saw the electric field formula as E vector is equal to 1 by 4 pi epsilon naught in air medium. This is the air medium. So 1 by 4 pi epsilon naught Q by R square into P cap. P cap is nothing but the electric dipole moment vector, which is unit vector. It is nothing but the direction of the electric dipole, which is always from minus Q to plus Q. So always from minus Q to plus Q. That is why I have denoted the arrow mark. So P cap. Now I'm going to find the electric field due to plus Q charge. Electric field due to plus Q charge. Due to plus Q charge at a point C. At a point C. And I'm going to use the distance BC, because it is for plus Q charge, and the plus Q charge, to find the electric field at a point C, I'm going to find the distance of BC. So in the place of R, I'm going to substitute the distance of BC, which is nothing but E plus vector. Now I'm introducing the symbol E plus vector. So E plus vector is equal to plus 1 by 4 pi epsilon naught Q by R minus A the whole square, because the distance BC is R minus A. So R minus A the whole square into P cap. I will say why I'm using plus here, because I'm going to use another symbol for the electric field due to minus Q charge. So when I need to find the electric field due to minus Q charge at a point C. And I'm going to use the distance AC. Now I know what is the distance of AC. AC is nothing but R plus A. So in the place of R, I'm going to substitute R plus A. Now here I'm going to introduce a negative symbol. Why I am going to introduce a negative symbol is, here the negative electric field is radially inward, and the electric field due to positive charge is radially outward, because electric field lines are attracted towards negative charge and electric field lines are repelled to positive charge. That is why E minus is coming inside. So whenever you take a graph, what is this? Whenever you take a graph, this is x-axis and this is y-axis. This is positive x-axis. So this is positive x-axis and this is negative x-axis. Now consider, now you are seeing this E minus vector is coming inward. So when the direction is like this, it is going in the negative direction. It will go like this. So I'm going to use negative symbol for this electric field, since it is moving in inward direction. That is why I'm going to use negative symbol in this formula. And I told that I'll explain why I'm using positive symbol, because the electric field due to plus Q charge is going radially outward, which is in the positive direction. So I am using plus symbol, and here I am using minus symbol, since the electric field due to negative charge is inward. So E minus vector is equal to minus 1 by 4 pi epsilon naught. In the place of R, I'm going to substitute Q by R plus A the whole square into P cap. Now I got the formula for electric field due to minus Q charge and electric field due to plus Q charge at point C. Using two distances, I have found this formula. Now I'm going to mark these two formulas as equation number 1 and equation number. This is equation number 1 and this is equation number 2. Now I need to find the total electric field at a point C. Due to this electric dipole. I need to find the electric field at this point. So what I'm going to do is, I'm going to add these 1 and 2 equation to find the total electric field. So now to find the total electric field at a point C, due to AB, which is nothing but dipole. E dot vector is equal to E plus vector plus E minus vector. Now I know the formula for E plus and E minus vector. Now I'm going to add these both. So E plus vector is nothing but plus 1 by 4 pi epsilon naught into Q by R minus A the whole square. And E minus, I know it as minus 1 by 4 pi epsilon naught Q by R plus A the whole square. And I know here we have P cap and here we have p cap. Without forgetting, we need to write the unit vector. And now I'm going to take common. What is common in this two terms? 1 by 4 pi epsilon naught into q is common, and 1 by 4 pi epsilon naught into q here is also common in these two both terms. And also p vector, this p cap is also common. So I'm going to take all the commons out of these two terms. So which will be getting like 1 by 4 pi epsilon naught into q by 1 by r minus a the whole square minus 1 by r plus a the whole square into p cap. Now this is in the form of r minus a the whole square, r plus a the whole square. Just take LCM, which will be nothing but LCM will be cross multiply r plus a the whole square minus r minus a the whole square by r minus a the whole square into r plus a the whole square. This e-tot vector from the previous steps, that is from doing LCM. Now the denominator is in the form of a minus b the whole square into a plus b the whole square. So this is in the format of this formula is in the format of this step. So now I'm going to adjust it into a general formula, which we know that a minus b into a plus b is nothing but a square minus b square. So in the place of square I have in the place of 1 I have square, so I'm going to replace it with the 2, and this term will become square. So in this formula I'm going to substitute this type. So in the place of a and b I'm going to substitute r and a. So this e-tot vector will become, total vector will become 1 by 4 pi epsilon naught q into, I'll solve the numerator, which is in the form of a plus b the whole square and a minus b the whole square. So a plus b the whole square is nothing but r square plus 2ra plus a square, and I have a minus outside, so I'll take a bracket. A minus b the whole square is r square minus 2ra plus a square. And I have a p cap here. So now the denominator will become r square minus a square the whole square, which is nothing but a square minus b square the whole square. So now I need to take the negative symbol inside, which will become 1 by 4 pi epsilon naught into q by r square plus 2ra plus a square minus r square plus 2ra minus a square by r square minus a square the whole square into p cap. Now I'm going to subtract r square and r square, because this is plus r square and this is minus r square, and I'm going to subtract plus a square and minus a square, leaving with 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught q into 4ra by r square minus a square the whole square into p cap. So now I got this e-tot vector is equal to 1 by 4 pi epsilon naught q into 4ra by r square minus a square the whole square into p cap. Now this 4ra can be written as 1 by 4 pi epsilon naught into q times 4ra can be written as 2r into 2a, because 2 into 2 is 4 and r into a is ra. So 4ra comes. So now 2r into 2a is 4ra, and r square minus a square the whole square remains the same. And now I know this from the definition of dipole moment, electric dipole moment. So this will become p cap. I'm going to multiply this q with 2a. So 1 by 4 pi epsilon naught into 2aq into 2r into p cap. I will bring the p cap inside by r square minus a square the whole square. Now we know that p vector, which is nothing but electric dipole moment, p vector is equal to 2qa unit into unit vector. Okay, 2qa is nothing but magnitude of dipole moment. So in the place of 2qa into p cap, I can take it as p vector. So in the place of 2qa into p cap, I can take p vector, which is nothing but electric dipole moment vector. So in the place of 2aq and product of 2aq and p cap, I can write it as 1 by 4 pi epsilon naught into 2r into, and in the place of 2aq and p into p cap, I can write p vector into p vector by r square minus a square the whole square in whole square. Now we got this equation E dot vector is equal to 1 by 4 pi epsilon naught into p vector dot 2r by r square minus a square the whole square. From this equation, we can infer that we have a special case, which is nothing but when the distance between the C, when the distance between the midpoint of the dipole and the C is greater than the value of A, when R is far greater than A, when R is far greater than A, then we can neglect A, we can neglect A value. So when the distance between the midpoint and the point C, midpoint of the dipole and the point C is greater than the value of A, we can neglect that A value. So in this formula, I'm going to neglect the A value. So I get the final equation in the special case as E vector tot is equal to 1 by 4 pi epsilon naught P vector into 2R by R square the whole square, which is nothing but 1 by 4 pi epsilon naught P vector dot 2R by R power 4. This is the special case.